Atlanta, Georgia, 1979. One by one, kids are going missing, with no explanation. There was a real-life monster on the loose. But nearly 40 years later, this case has left more questions than answers. From the producers of Up and Vanished and How Stuff Works, we present an all-new podcast, Atlanta Monster. Subscribe to Atlanta Monster right now on Apple Podcasts and be the first to hear it on January 5th.
Get in touch with technology with TechStuff from HowStuffWorks.com.
Hey there and welcome to Tech Stuff. I am your host, Jonathan Strickland. I'm an executive producer at How Stuff Works, and I'm in pain right now. People who are watching the live stream know that just before I recorded this episode, I ate a Carolina Reaper corn chip. So if you want to watch me do dumb things immediately before I do my job, go to twitch.tv/techstuff and you can watch me record these live. But let's put that aside. First of all, Happy New Year. Welcome to 2018. I'm recording this at the end of 2017, but by the time it goes out, it'll be 2018. So I'm sure the new year has transformed everything around us and we don't even recognize the world of tomorrow, which I guess is today for you. But today I wanted to talk about a technology that's been around for a few years. Actually, elements of this technology have been around for decades. But people are talking about it now more than ever and mentioning it as the technology of the future. And what I'm talking about is the technology of blockchain. So this is an interesting technology. It's safe to say that I think, the most famous example of something that's dependent upon blockchain technology is Bitcoin. Everyone's heard about Bitcoin at this point. But it is important to remember that Bitcoins are an implementation on top of blockchain technology, but not all blockchain technology has to be Bitcoin. So what the heck is blockchain? Well, I'm going to talk about blockchain. I'm going to talk about Bitcoin. I'm going to talk about other uses of blockchain. But we will mention Bitcoin quite a bit because, again, it's the most famous implementation of blockchain technology. And the reason why anyone is really talking about it at all today, because it showed the potential for this technology. Now, it's the implementation of a collection of different really good ideas put forward in an innovative way to create a distributed record of transactions. We can trace this technology back to a name, but not to an actual person. And by that, I mean we can trace the concept to a person or group of persons who used the name Satoshi Nakamoto. And if that name sounds familiar, it probably means you've read up on Bitcoin because that's where blockchain got its start. It was all in this white paper that was written about Bitcoin by someone or someones going by the name Satoshi Nakamoto. Now, the mystery of who is Satoshi Nakamoto is interesting, but rather immaterial to our subject matter. So let's just say there's a lot of speculation as to who ultimately is behind the pseudonym. According to at least one post from Nakamoto, supposedly is someone from Japan who was born in 1975, but there's been a lot of speculation that that is just misdirection. And in fact, Nakamoto is really someone who is originally from America or the European Union, and that's all we know, really. Now, what's really important to us is that Nakamoto published a paper on a mailing list that focused on cryptography, and this was back in 2008. The first message in that thread of messages was titled Bitcoin P2P eCash Paper, and it hit that mailing list on Saturday, November 1st, 2008. That's what I love about the internet. It means that if you go to a message board, you could actually see the date when something is posted, so you can have a very specific mention of when something came into being. In fact, I could even give you a timestamp if I still had that page open to tell you what time it was posted there. But the message contained a link to a paper, a white paper, about this concept. And that paper is still available in PDF format for free. So if you'd like to read the whole thing, you can find it at bitcoin.org/bitcoin.pdf. Now, a lot of what I'm going to cover today comes straight from that paper. Now, the abstract of that paper lays out Nakamoto's general approach. So I'm going to quote the abstract here. A purely peer-to-peer version of electronic cash would allow online payments to be sent directly from one party to another without going through a financial institution. Digital signatures provide part of the solution, but the main benefits are lost if a trusted third party is still required to prevent double spending. We propose a solution to the double spending problem using a peer-to-peer network. The network timestamps transactions by hashing them into an ongoing chain of hash-based proof of work, forming a record that cannot be changed without redoing the proof of work. The longest chain not only serves as proof of the sequence of events witnessed, but proof that it came from the largest pool of CPU power. As long as a majority of CPU power is controlled by nodes that are not cooperating to attack the network, they'll generate the longest chain and outpace attackers. The network itself requires minimal structure. Messages are broadcast on a best effort basis, and nodes can leave and rejoin the network at will, accepting the longest proof of work chain as proof of what happened while they were gone. So this is all about keeping that record of transactions that take place across a system, and the ongoing record that keeps getting built onto is also used to verify everything that happens and to make certain that people are not able to spend the same units more than once. Now, Nakamoto was specifically talking about creating a digital currency, namely Bitcoin. But it turns out this decentralized peer-to-peer ledger system could be used for lots of different stuff. Essentially, any sort of transaction, not just the ones involving spending digital currency to purchase goods and services, or even storing data online. It would serve as the foundation for blockchain, which some people are going so far as to call Web 3.0, which I absolutely hate. But that would send me down a rant about Web 2.0, and I've already done old episodes about that years ago, so we'll not retread that ground. To understand blockchain and why so many people are convinced that it's going to be the tech of the future, it helps to understand how transactions work in a traditional system. So let's start super basic with bartering system. So this is the old tit for tat approach. You have something I want, I've got something you want. We agree upon the relative value of those two things, and we do an exchange. So let's say you make chairs and I breed chickens, and we have to agree how many chickens does it count to be valuable as a chair, or vice versa. And then we make the exchange. Pretty straightforward system, but it has some major downsides. One of the big downsides is I might really need that chair, but it may turn out the carpenter has no need for my chickens. So it doesn't matter how many chickens I offer against the chair. The carpenter has no use for the chickens, so I don't get the chair and I'm unable to sit down and I am sad. Now I could go out and try and find a different carpenter who does need chickens, or maybe I find someone else who needs chickens but is offering up something else entirely and hope that whatever that thing is something that the carpenter wants and I exchange that for the chair. But this whole process is cumbersome and messy unless the two parties in question already possess exactly what the other party wants. Now, another drawback is portability. It'd be a real drag to carry chairs and chickens around everywhere you went just when you needed to buy something. So currency alleviates that problem. It acts as a store of value. Members of a population agree upon what the units of that type of money are worth in comparison to goods and services. And it's easier to carry that stuff around than actual products. So step one in a currency is to have everyone agree that yes, this currency, this money represents value, and that the value is steady enough for us to make transactions happen. So in other words, when I go out with my dollar bill and I'm ready to go buy something, I know that by the time I get to the store, that dollar bill is worth more or less the same as it was when I left the house. This is actually one of the big criticisms leveled against Bitcoin, by the way. The value of Bitcoin changes so dramatically, so quickly, that it discourages anyone from using it as an actual currency. In fact, people have said that by the time a transaction can complete, the value of the Bitcoins can change so dramatically that it completely changes the nature of the transaction itself. But we'll get into that a little bit more a little bit later on. Now, most currencies require some sort of backing institution to work, and that might be a government or a bank or a combination of the two. And this is an entity that can help guarantee the value of a currency and that it remains stable. Also, it can act as a third party during certain types of transactions. And third parties become even more important when you start getting into concepts like credit. You could have a specific credit with a particular store or vendor, but these days it's far more common to see people build up credit with an agency and use a credit card to make purchases against that credit. Now, transactions require the involvement of additional agencies to verify that the person making the purchase has the available credit to do so, and that the vendor is authorized to accept such credit. As more societies and populations interact with one another, this process of transactions becomes way more complicated. So then you've got things like exchange rates for currencies, and you've got processing fees for payment service providers. You've got various ledgers to keep track of purchases and sales. Information tends to be in silos. It is not transparent. It is privately held, which means you're not able to really get a look at it. They're all independent from one another, and this creates potential vulnerabilities that less honest people can exploit. Then you've got the concept of disputes. Disputes can become a point of exploitation. Third parties frequently must mediate disputes between buyers and sellers. Now, a dispute could arise for many reasons. For example, it may be that the delivered goods don't match what was advertised. In the case of physical goods, this can be a hassle. In the case of services, it's even more thorny, because how do you get a refund for a service that's already been rendered? Even if that service wasn't what you had hoped for, you did get something out of it, and you can't return it. It's a service, not a product, so it's problematic. These third parties have to spend a lot of money mediating disputes between these buyers and sellers, and they tend to recapture those costs by increasing the transaction fees they charge for using their services. The transaction fees are what the amount of money that gets paid to the service, as opposed to going straight to paying off the vendor for whatever you're purchasing. This makes smaller transactions less practical, since more of the transaction itself is going to this processing fee than it is to revenue for the merchant. This is why you might encounter some vendors that have a minimum charge amount for any credit card purchases. Now, this in turn becomes an issue of trust. And since trusted third party is part of the name, you can imagine that's a big deal. Merchants might demand more information from customers before accepting a specific type of transaction, because without knowing more about their customers, the merchant might worry about fraudulent disputes. A fraudulent dispute may cost them money. They might have to foot the bill, and they end up getting the raw end of the deal. They might end up being out of a product, and they don't get paid for it. So this is particularly an issue with online payments. You can make exchanges using actual currency in person, and that avoids many of these problems, because you don't need a third party. It can just be a direct exchange, like, here's my money, thank you for the thing, I'll be on my way. But if you're buying something online, that's not really an option. You essentially have to use some other third-party service, whether it's credit card or PayPal or something along those lines. There really wasn't a way to make a purchase without also relying on a third party. And as a result, those third parties tend to be big targets for hackers. They go after them because this is sort of the central point where a lot of money has to pass through on any given day. Now, Nakamoto's design was meant to change all of that. Third parties would become obsolete because the system itself would serve as a record of transactions, and also the authorization tool required to verify those transactions. The verification process would create a situation that was, in the words of Nakamoto, quote, computationally impractical to reverse, end quote. Now, that meant that the amount of processing power required to change the transaction record so that you would be able to commit fraud would require so much computational power that no one would have ready access to it. In addition, the record of transactions would exist across an entire peer-to-peer network, so you would have to do so much work to commit fraud that it would be a diminishing returns situation. You would actually be spending more money trying to get ahead of the system than you would ever recapture from committing fraud. In fact, it would make way more sense to dedicate that computational power to working legitimately within the system and earning money that way. But we'll talk about that a little bit more later on. Before I get into that, let's take a quick break to thank our sponsor.
Hey, my name's Jack. I'm the founder and former editor-in-chief of Crack.com and the host of the new How Stuff Works comedic news and pop culture podcast, The Daily Zeitgeist. Our goal is to tell you about the ideas that are out there changing the world. We talk politics and news, but we also cover supermarket tabloids, which might seem stupid, but millions of people pass those every day, and they absorb the ideas on the cover whether they want to or not. We also take movies pretty seriously because when we picture something that we haven't experienced, you generally use movies. You probably picture Terminator 2 when picturing a nuclear explosion, even though that's not actually what they'd look like. Anyways, we're trying to take the temperature of what's affecting the national shared consciousness, which sounds a little more hippie-ish than we actually are. But fair warning, guys, some of the content can get a little edgy, so not for young ears, but trust us, it's all in good fun. So go to Apple Podcasts and listen and subscribe to The Daily Zeitgeist. It's very good, is our catchphrase. We're kind of workshopping it.
The peer-to-peer decentralized network I was talking about, that's the key here. It's what gives transactions legitimacy and transparency. It keeps the system itself stable, even if it's a cryptocurrency system like Bitcoin. Even if the cryptocurrency has a fluctuating value, the system itself is still stable. It's also necessary so that no party can abuse the system, such as spending the same digital currency twice. Now, what I mean by that is, well, let's take a real physical world example and then compare it with a digital example and see how they're different. Let's say that you have in your possession a valuable physical commodity. We'll say it's a vinyl single. In fact, let's say it's a vinyl single of the greatest song ever written, which we all know is Hooked on a Feeling by Blue Swede. So a friend of yours is willing to trade a sweet, hollow, shadowless Mewtwo Pokemon card in exchange for your limited edition vinyl single of Hooked on a Feeling. So you make the trade. You hand over the single, they hand over the card. And once you do, that vinyl single is no longer in your possession, right? It's gone. You've given it to your friend. So you can't spend it again. You aren't able to make that trade a second time with someone else. But let's switch this to the digital world. Let's say that you've convinced the same friend to part with that sweet, sweet card in exchange for an MP3 of Hooked on a Feeling. Well, that's gravy, because you can make endless digital copies of the MP3, and you can spend it over and over in trades like that. So if you find that your other friends also want an MP3 of Hooked on a Feeling, then you can just keep on trading that same file. You're just copying it over and over again. So it's like you're spending the same dollar repeatedly. Clearly, if you want a digital currency to work within a system, you have to build in a mechanism to make sure someone can't just spend the same units of currency repeatedly. It has to be able to track when something has been spent and mark that down so that you cannot spend it again because you no longer possess it. Once they make a transaction, the unit of currency has to be transferred to a new owner with no copy left behind. The distributed ledger helps ensure this by making sure everyone has a copy of what's going on, and it avoids the issue of having a centralized authority like an exchange or a bank or a government that is in charge of saying, yes, that transaction was legitimate. Because again, if you have a central point, then that's the point that's the most vulnerable. Everyone's going to attack it. If it's distributed, it's way harder to take advantage of it because it's spread across an entire network of computers. So a distributed ledger helps ensure this safety. Everyone in the system can see the record of transactions, and thus everyone knows if you've already spent those digital units. The distributed ledger is sort of like a shared online document or a spreadsheet. So if you've used something like Google Spreadsheets in a shared work group, that's an okay example. It's not exactly the same thing, but it's similar enough that we can kind of draw some analogies. So you have authorized users who can access and view and edit the same spreadsheet. They don't possess a localized copy of the spreadsheet the way you would with something like traditional versions of Excel or Lotus 1-2-3. And this is a good thing, because in the old days of working with these documents, you might get a copy of a document, you'd make some changes, you would save it, that would create a new copy of the document. Somewhere else, the older version still exists because someone sent that to you. You then send your version to somebody, They make changes, they save it. Now there's a third copy out there, and so on and so forth. And you end up with all these different copies of a document. You ultimately have to reconcile them all, decide which one is the definitive copy, which one has the most accurate changes in it. And it's a huge hassle. If the other person had made some changes that you didn't agree with, and you got to go back and forth on this. And the separate instances of the same sort of file create a huge amount of headaches. Blockchain ledgers kind of get around this by having a shared document where everyone can see it. Now, granted, it's kind of like there are copies everywhere, but every copy of it has to agree with all the other copies ultimately. It gets a little messy in the short term, but in the long term, all the copies have to agree with one another, and they're distributed across the entire network. So it's more like a shared spreadsheet, where if I make a change in that spreadsheet, everyone else will see that change. Or really, I should say, if I make an addition to it, because the way blockchain has worked, it's meant to allow for more information to be added to the blockchain, the chain of blocks, and each block is a block of data. So blockchain ledgers are a record of transactions. In fact, they are a record of transactions that date all the way back to the formation of the blockchain. And this is a distributed record, meaning every computer, or node if you prefer, because that's what these computers are called, every node on this network and this peer-to-peer network can access that ledger. So to perform a transaction with Bitcoins, because again, Bitcoins being the most famous implementation of the blockchain technology, first, you need a wallet, and the wallet exists as your repository of Bitcoins. Associated with the wallet are two security keys. One of them is a public key, which you share with other people on the network, and one is a private key, which you keep for your very own. The keys are connected to one another, but they are different. So the public key and the private key are not the same code, essentially, or same characters, if you prefer. But they are connected to one another. Encrypting a message with a public key makes it impossible, essentially, to read without the corresponding private key. So if you wanted to send me a message, and you wanted to make sure that I was the only person who could read that message, you would use my public key, which everyone has access to, and you would encrypt your message. Now, the only thing that can decrypt that message is my private key, and I'm the only one who possesses it. So that way you know that the message you're sending me is safe until I open it, because I'm the only one who has the key to access it. Likewise, if I send something out with my private key encrypting the data, that's like a digital signature. That's saying this message had to come from Jonathan Strickland because it used his private key. And I know that because I can decrypt it with Jonathan Strickland's public key, which I have access to. And that means that it's authenticated as coming from me. Now, these are both very important concepts when it comes to transactions. If I send out a message that I want to make a transaction and use my private key, then again, only my public key, which is known to all nodes on the network, can decrypt this message, and that authenticates that the message actually came from me, no one else, no one's able to impersonate me and spend my money on my account. So all the nodes can see that ledger, and when it's time to make a transaction, the parties involved send a message out to the network using their cryptographic keys. And a simple way to think about this is that one party's Bitcoin wallet will decrease by a certain amount, and the other party's Bitcoin wallet will increase by that same amount. So let's say I'm buying something for 0.0005 Bitcoins, because you can divide Bitcoins up to like 100 million places. And the message that's sent out to the network is Jonathan's wallet should decrease by 0.0005 Bitcoins, and the Queso Hut's account should go up by 0.0005 Bitcoins. Although I should point out that the blockchain isn't actually keeping track of how much money is in my account. It doesn't care. Instead, it keeps track of where all the units of currency in the system are, because all that history is contained within the ledger. The nodes have to verify that I actually have 0.0005 Bitcoins, and they do that by looking at the transaction history, all the transactions where money was deposited to me versus money coming out of my account, to make certain that I actually have that amount. So it's not really looking at my account balance so much as it's just looking at the transaction history. It's kind of a fine line to look at, but that's how the system works. And if I do have those units, then it will verify my transmission of those units to Queso Hut. And if it works, then I get queso, which makes me happy. Now the nodes will add this transaction to their individual copies of this shared ledger. And the new transaction will join other transactions made at that same time to form a block, this data. So think of it, think of it like a physical block. That block represents a certain number of transactions that took place within a given amount of time. A new block forms approximately every 10 minutes. That's designed by the creators of the Bitcoin blockchain experience. They wanted it to be on average 10 minutes for it to generate a new block of this. At the very least, you get a generation of a block that will release more Bitcoins into circulation. This is the process of mining, where you get new Bitcoins to enter the system. So in the case of Bitcoins, you do this so that you can earn more, but other blockchain implementations might go a totally different way and not use any kind of cryptocurrency at all. Although you have to figure out some way to give an incentive to people to actually operate the nodes in order to verify these transactions, because it does require some computational work to do this. So there's a balance there. The blocks have to be validated. So you've got all these different nodes on your system that are all working to form the next block in the blockchain. And to validate a block, to validate that list of transactions, it requires a certain amount of computational power. And it's a good amount of power at this point. Once a block is validated, then it joins the chain of blocks of transactions that came before it. And in fact, the value of the new block is partly determined by the value of all the preceding blocks. Because each verified block contains values of those previous blocks, trying to fool the system so that you can spend the same Bitcoins twice is really hard to do, because every 10 minutes another block is being added to this blockchain, and pretty soon you've got your transaction that you're worried about that's far behind the most current block of transactions. So I'll give you an example. Let's say that I'm a dishonest jerk so-and-so, and I want to spend some Bitcoins, but I already spent them in the past. In fact, in this particular blockchain, random example, the transaction I made happened in block number 42. And later on, I decide, hey, there's this other stuff I want to buy, but I've already spent all my Bitcoins. But if I can fool the system into thinking I never spent the last ones, then I could spend them again and buy this other thing I want. However, that transaction was all the way back in 42, and every block that went after 42 has that information built into it, and it's currently up to block number 67. Here's the thing about blockchain. Whichever blockchain is the longest is considered to be the most valid. So if you could dedicate enough computational power, in theory, you could go back, change the data in block number 42, but then you would have to solve all those computational problems and rebuild blocks 42 through 67 and then get to 68 before the rest of the entire system could get block 68. So you would have your one computer or even family of computers working on this problem. Meanwhile, the entire Bitcoin system would be working against you just in the regular process of validating all the transactions. So the likelihood of you being able to catch up and then pass the rest of the blockchain system is next to nothing. The only way that you could really commit fraud on this system is if you controlled more of the computing power on the system than legitimate nodes in the system. So if you had more than 50% of all the CPU processing power in the Bitcoin blockchain family, if you possessed that much of it, then you could potentially commit fraud. However, it would be way easier for you to just use it legitimately and make more money that way than for you to go back and spend the same money you spent ages ago again. In other words, it makes more sense to follow the rules because you're going to make out like a bandit than it would if you tried to actually be a bandit. It would be less profitable and more frustrating. So Nakamoto says the entire design of the system is such that it discourages cheating in this way. So it convinces you to play by the rules rather than try and cheat, because you're way more likely to make headway playing by the rules, more or less. Although these days, you got to have a whole lot of computers to really have a chance. Now, the process of validating, like I said, is called mining, and it's called that because whichever node validates the next block in the chain earns a certain number of bitcoins, which changes over time. Every few years, it halves in amount. So eventually, you'll get down to fractions of bitcoins, and then ultimately, you're going to get to a point where all the bitcoins that will ever exist will be in circulation, and you'll never create more. But in the meantime, it's incentive for people to participate in the system and validate those transactions because they get something out of it. By validating transactions, they get rewarded these bitcoins. So participating means earning money. You accumulate wealth in this way. Really, I shouldn't say earning money. I should say wealth, because it's slightly different from money in my opinion. Now, more specifically, for a block to be valid and become the next block in a blockchain, it must contain the answer to a complex mathematical problem that's created through a cryptographic hash function. And the way to solve this problem is guessing. Yep, you got to guess random numbers, and these random numbers will combine with the previous block's content in order to create a specific result. According to a Medium article titled "How Does the Blockchain Work?", which is pretty good article, I recommend reading it, it would take a typical computer about a year worth of processing to suss out the problem for a single block. But in the world we live in, where people are dedicating hefty processing resources like grids of computers in order to solve these problems and to validate blockchain transactions, it takes about 10 minutes. And again, that was by design. This is also why you might hear people say that there's no point in getting into Bitcoin mining unless you can make an enormous investment in computing power up front, because there's just no way to compete with the more beefy mining operations out there. They're using way more computer processing power. It's also why graphics cards can be hard to come by, because as it turns out, graphics processing units are really, really good for those kinds of problems. Fun fact though, the system actually adjusts the difficulty of this math problem based on the amount of processing power thrown at the math problems. I'll talk a little bit more about that later, but in other words, the harder you try to find them, the harder they are to find. All right, so you've got this concept of validating a block, and you've got all these different nodes working to do it. They're all trying to guess at this random number and find the right random number so that it can end up adding the next block to the blockchain and getting this Bitcoin reward. But what would happen if two or more nodes came up with the right solution at the same time? Well, each of those blocks could potentially be the next one on the chain. So they almost all kind of occupy what the next block would be, but none of them are solidly connected to the blockchain yet. What will then happen is the system will continue to validate the next block of transactions. So this would be 20 minutes out from that original moment. And if one of those nodes is able to put up the next block of transactions that adds on to one of the previous ones, that becomes the longest chain in the group. That one becomes the valid answer, and the others are discarded. So one example I saw said, let's say you've got three different nodes, A, B, and C. And A, B, and C all present their solutions at more or less the same time, so they could each be the next block on the blockchain. Well, they're all just kind of nebulously hovering at the very end of the blockchain, but none of them have solidly been connected yet. And then you get solution N for the next block, the one after either A, B, or C, and it's attached to block B. Well, that means that block B is now part of the longest chain, because it's not just B, it's also B plus N. And because A and C do not have another block after them, they're discarded. Those are no longer the right blocks for that blockchain, and they don't earn any bitcoins. Womp womp. So, interesting system. Essentially, it rarely happens that nodes present simultaneous answers, but it is possible. It's just that eventually, down the line, one of those chains is going to be longer than the others, and it will end up becoming the official one. So the system self-corrects after at least a few blocks. Now, there are some drawbacks to the Bitcoin world, and one of those is that it's not difficult to lose access to your owned Bitcoins. If you forget your password to your wallet, or you lose access to the machine that your wallet is on, you're out of luck. There's stories about people who have lost potentially millions of dollars worth of Bitcoins because they no longer have the hard drive the wallet was stored on, or they lost the password or whatever. It's terrible stories like that. There are also third-party services that act as Bitcoin wallets, but these are prime targets for hackers and thieves. More than one Bitcoin wallet company or Bitcoin exchange has had to explain to customers that hackers managed to steal a significant sum of Bitcoins from the service. And it turns out trust is still needed in this post-trust economic environment. And the only reason for that is because you had to have these other entities in place to facilitate transactions. And that's where the real problem was. It's that there's that again creates this target. It's not distributed across the entire network. It has these little focused points that hackers can look at and say, let's aim at this and see if we can make away with a big old digital heist. Another drawback of Bitcoins is liquidity. Being able to convert Bitcoins into some other form of wealth that you could actually spend, because as it turns out, Bitcoins are very hard to spend, largely because their value can fluctuate so dramatically from the beginning of a transaction to the end of one. And several people have complained that it's difficult to offload Bitcoins when you need to. Again, if you decide to offload your Bitcoins and in the process of actually trying to validate that exchange, the value has changed to the point where you wouldn't have gotten rid of them, it kind of freezes you. And also, it's hard to find buyers. Everyone wants to get at Bitcoins, but not a lot of people want to actually spend the money to buy them. So it does get very complicated. Also, there's just a few hundred Bitcoin owners who possess enough of the percentage of Bitcoins in circulation that they could completely upset the economic order if they were to offer up their Bitcoins for purchase at around the same time. If they were all to sell their Bitcoins, then it would be almost akin to a run on the banks. People predict that such a thing would make the prices plummet afterward. So you get these large entities, these people or organizations that own a ton of Bitcoins making an enormous amount of money in the short term, and then the value of Bitcoins would drop out from under it as a result. In the Bitcoin community, those entities are referred to as whales. Now, I've got a lot more to say about blockchain technology, but before I do that, let's take another quick break and thank our sponsor.
I'm gonna make an offer he can't refuse. Phone home. You built a time machine out of a DeLorean? Hey everybody, this is Chuck from Stuff You Should Know, and if you didn't guess, that was me doing bad impressions to talk about my new show, Movie Crush. It releases every Friday on Apple Podcast or wherever you get your podcasts, and each week I sit down with an awesome person to talk about their favorite movie. Go check it out. If you love movies, if you love great conversations, you're gonna love Movie Crush.
Now, as I've said, the whole process that we've just talked about is used by Bitcoin to validate cryptocurrency transactions, but that's just one potential use of blockchain. There's a Wired article that is titled 2018, the Year of the Cryptocurrency Craze, and it talks about how blockchains can be used for anything that you can make a list of, like land ownership. So not only could you make such a system so it's easier to deal with those sort of transactions, the system itself becomes the record of ownership. It's like a deed or a title to a car. If I were to purchase land using a blockchain approach, that transaction would become part of the blockchain's history. So if some huckster wanted to try and post as the legitimate owner of the land and try and sell it to some sucker, which is the old, I got this bridge in Brooklyn you got to see routine, the system would reject this transaction because the nodes in the system would start looking for the digital information that represents that parcel of land in its transaction history and try to verify that the land does, in fact, belong to the huckster, that at some point in the past, I sold or traded this land to that person and it's connected to the system. And once the nodes look back and they see there's no such record, that's not the case, they can reject the transaction and the con man cannot fleece another mark. Because the system knows, oh, looking at this record of transactions, I see that the actual true owner of the land is Jonathan Strickland. So I know that this is a fake attempt. But if I were to sell that land, again using this blockchain system, the nodes would first verify that I'm the rightful owner. They would look through that transaction history. They'd say, yes, Jonathan bought that land at this timestamp because here's the record within my system. And it would then make sure that I had not at any point gotten rid of that and given it to someone else or sold it to someone else. Once a node validates that, a new transaction can be authorized and I can sell the land to a new owner. And all the records in the system update with this transaction across the entire peer-to-peer network. And everyone knows that the ownership of that land has changed hands. And I wouldn't be allowed to sell that same land again because the system reflects that I no longer own it. Now, this is one of the most powerful aspects to the blockchain approach. There's no need to appeal to some sort of authority figure. You don't need a government or a financial institution to keep a record of all the transactions. You don't need notaries. You don't need any verification that this is a lawful transaction because the economic system itself keeps that record and verifies it. The process secures itself as it's perpetuated. So it's kind of like a self-policing system just based on the way it's designed. And because of that unalterable record, there have been other suggested uses for blockchain technology. For example, using it to keep track of supply chain issues. I've seen it for food services. The idea being that by connecting everything, you could more easily identify if a potential problem comes up. Let's say that there's a disease outbreak that could affect a certain kind of crop. You could check the blockchain and use that to prevent that food from entering into the rest of your supply and thus contaminating potential customers. The precious gems industry is looking into using blockchain in order to trace diamonds and other gemstones to make sure the ones on the market aren't conflict gemstones. So they make sure that the ones that are on the market are all from legitimate sources that haven't been using forced labor or other awful methods to mine those gemstones. There's a cloud storage company called Storj, S-T-O-R-J, which uses blockchain technology to create distributed data storage banks. So it encrypts the data, but if you have the key, you can decrypt the data, and you would, when you retrieve a document from this cloud service, it sends it from whatever would be the closest / fastest computer on the system to you. So whichever node would be able to most quickly get the data to you, it sends it from there. And the idea is that this not only creates a distributed storage network, but it also speeds things up a little bit through that actual architecture. For many types of information, blockchains make a lot of sense. Anytime you want a public record of transactions or changes, a blockchain could be a good solution. There needs to be some sort of system in place to create an incentive to participate in the blockchain, since the process of validation requires computational power, and that in turn means there are energy costs to consider. In other words, validating transactions comes at a cost. So there needs to be an offset of those costs to make the system viable. In the case of Bitcoin, the incentive is more units of cryptocurrency, more Bitcoins. Miners are rewarded for their computational power by potentially earning more Bitcoins through validating transactions. But it's a first-come, first-served approach. That in turn creates an incentive among miners to consistently turn more computational power toward validating blocks, and it can even lead hackers to create armies of botnet-like computers just to help mine for Bitcoins. So they're not going after your data, they're not trying to send you spam, they're literally trying to infect your computer so they can turn it into one of the 7 dwarfs as they mine for Bitcoins. In fact, Bitcoin mining is responsible for an awful lot of energy consumption. According to the Digiconomist website, Bitcoin mining consumes 32 terawatt hours of power annually, or 250 kilowatt hours per transaction. Now, 32 terawatt hours is equivalent to the power consumption of Denmark over the course of a year, more or less. And 250 kilowatt hours is the same amount of energy you'd use to power your home for more than a week. Eric Holthaus predicted that by 2020, Bitcoin mining will consume as much electricity as what the entire world is using this year in 2017. Well, last year for you guys who are listening, because it's coming out early 2018. That's pretty dramatic. But it turns out it's not really as simple as that. Because here's how it boils down. The more energy you use, the more you will ultimately have to pay. Because you're using up more energy. There's a certain amount of energy rate that you're paying. The more you're using, the higher that electric bill is going to be. If you're using so much energy that's requiring power companies to supply even more than they normally would, energy prices as a whole will also increase. So not only are you using more per unit of time, but that cost per unit of time goes up. This is the basic idea behind supply and demand. Your demand for energy has increased. The supply has not necessarily increased, at least not simultaneously with demand. Prices go up. Well, if prices go up, that starts to eat into your profit as you mine Bitcoins. There's no guarantee that you're going to find the next block. So if the energy prices increase to the point that it's no longer profitable to do Bitcoin mining, you'll ease off. You'll create a little relief on the system. Now, the difficulty of those complex mathematical problems isn't static. I mentioned earlier, it's dependent upon how much processing power is being thrown at them. So every 2016 blocks, the blockchain system takes a look at how long the average block went before it was validated. The goal is to keep that time as close to 10 minutes per block as possible. Now, if there's an enormous amount of computing power directed at the problem, that means the mathematical problem has to be harder to solve to balance out the massive amounts of computer power that's being shot at it. But if people start dropping out of mining because it's getting too expensive to run the computer systems that are validating these blocks, the energy bills are so high that there's no more profit, people start to drop away. People back off. The system will actually notice this. They'll see that it's taking longer and longer to validate a block of the chain because there's not as much processing power being thrown at it. So then it will adjust that computational problem. It'll make it less difficult to solve to try and get back to that 10-minute mark. So it gets easier to solve blocks. And meanwhile, because the profit margin's been whittled away and energy prices are high, more and more miners have dropped out of the system, at least temporarily, which decreases the demand for energy. Prices will gradually readjust and become lower again, and it becomes profitable to mine Bitcoins all over again, and the whole process starts up. Now, a lot of these companies are using various types of cryptocurrency as an incentive to be part of this, and some of them are using cryptocurrency in a way as to say, this is an investment, and your investment into the system will eventually pay off in profit because the value of what you hold will increase over time. Others say your participation in the system is what gives the system value. So the more people who participate, the more valuable the system is, and the more you will get out of it as a result. So it's two slightly different approaches. And a lot of these companies are using what they're called ICOs, initial coin offerings. It's kind of like an initial public offering, except instead of offering up stock, they're talking about offering up cryptocurrency or tokens in a system so that they're able to do whatever it is they're trying to do. And that could be pretty much anything. It's an interesting world, and there are a lot of people who are wondering if this is going to be the next evolution of finance, or if this is going to be a bubble that once it bursts, it doesn't recover. Some people are pretty sure that there's going to be a bubble that bursts, and it'll be fine after that, after the market readjustment. It's just that people are going to lose a lot of money in the short term, but it'll survive and keep going. And then there's some people who say, no, this thing is going to inflate to a point where people are going to be, on paper, millionaires, and then it's going to crash, and then the various cryptocurrencies will be worth nothing, and people will abandon it because of that massive failure. What actually turns out, we'll have to wait and see. Honestly, I think that cryptocurrencies are here to stay, but I do think we're going to see occasional market corrections, as they say, and we'll see that value drop precipitously a few times. We've actually seen that at the end of 2017, where There were times where the cost of a Bitcoin was more than $16,000, and other times when it was less than $8,000. And it was just fluctuating back and forth wildly day to day. That's probably going to keep going for a while until there's a real market correction, and then we'll see maybe steady gains from there on out. That's a guess on my part. Well, that concludes our talk about blockchain technology, the technology of the future. I look forward to doing a whole lot more episodes in 2018 and talking about all sorts of tech, whether it's old or new. Who knows? Maybe our next one will be some sort of ancient technology, maybe something like ancient or maybe like 19th century medical technology, because I was just thinking I need more nightmare fuel material, and that'll certainly supply it. But maybe you have suggestions for things I should talk about in future episodes of Tech Stuff. If you do, you can send me a message. The email address for this show is techstuff@howstuffworks.com, or you can drop me a line on Facebook or Twitter. The handle for both of those social networks is TechStuffHSW. Again, I record these shows live on twitch.tv/TechStuff every Wednesday and Friday. So just swing by there. You'll see the schedule. You can join in, be part of the chat room, and watch as I fumble my way through the world of technology, bravely and with abandon. And with that, I'll talk to you again really soon.
For more on this and thousands of other topics, visit howstuffworks.com.
Hi, I'm Robert Lamb.
And I'm Joe McCormick.
And we're the hosts of the science podcast Stuff to Blow Your Mind.
On Stuff to Blow Your Mind, we put science on a collision course with philosophy, history, religion, mythology, and the worst space vampire movies of all time.
We examine neurological quandaries, cosmic mysteries, evolutionary marvels, and our transhuman future, all in order to decipher the nature of our reality and expand the mind.
Subscribe to the Stuff to Blow Your Mind podcast wherever you get your podcasts.
And learn more at stufftoblowyourmind.com.